when I present online, there's always that sort of moment of terror of will I be able to share my slides and will it work? And I'd forgotten it's actually a little bit the same presenting in person too, because AV is just a mystery to all of us. But what I want to start out with is, let's talk about shopping. Because we may not like grocery shopping, but I think all of us really like new things. And we especially like new things if they're new technology things. That feeling when you get a new MacBook and it's in the box, and the box is shrink wrap, and you take it off, and then you open the box, it's wonderful, right? And even in our jobs, I think we all like new things. We like new toys, we like new technologies. And at the moment, in 2022, the new technology that we all kind of want in our job is cloud native. And like anything else new, when we hear about it, what we want to do is get it, ideally with the least amount of work possible. So we want to say, let's take this thing, let's install it, let's download it, and then we're good, and we're sorted, and we are cloud native, we have bought cloud native. And cloud native, it's sort of sometimes hard to think, well, what are we talking about? But increasingly, cloud native is associated with technology, and it's associated with technology choices. So I've been saying for a while that maybe we should be thinking about something a bit more than technology. And Sam Newman, author of Building Microservices, has been saying a similar thing. What he's noticed is that when he goes out and he talks to people about cloud native, when he goes out and he talks to people about microservices, they start by saying, well, I need Kubernetes, right? I can't be cloud native unless I have Kubernetes. Well, actually, you can be very cloud native even with Kubernetes. And unfortunately, you can be very uncloud native even if you've bought all of the Kubernetes. Now, there is a certain irony here. I am aware of that. I work for Red Hat. My employer would really love it if your employer went and bought an OpenShift subscription. And my particular job is I'm a software engineer on the Quarkus team, so I help build Quarkus. Like everything that Red Hat does, Quarkus is open source, and it's even more free than most of the things Red Hat does, because even if you try and buy Quarkus, even if you want Quarkus support, it just comes free with OpenShift. So I would love to sell you Quarkus, except I can't actually sell you Quarkus because it's free. By the way, so this probably isn't the sort of the biggest sample, but how many of you are Java folks? Cool, okay. So, because if none of you raised your hands, then you definitely Ultra couldn't buy Quarkus because it's part of the Java ecosystem. So we'll just move swiftly past the irony of me saying don't buy things while hoping that you will buy things, and go back to cloud native. Because if I say we're going to buy cloud native, I'm the CTO, and they've said, okay, I need to become more cloud native, so I've got my cloud native shopping list, and I go and I look at the technology shelves. What even is it that I'm actually trying to buy? And we can narrow it down. I think it's maybe in this section of the supermarket. I think it's probably not. I don't need to bring in any waterfall consultants if I'm trying to become cloud native. I probably don't need to hire COBOL developers if I'm trying to become cloud native. But now that I'm in this section, what is it? And there's, unfortunately, a lot of different definitions floating around. I mentioned that a lot of people associate cloud native really strongly now with Kubernetes. A lot of people associate it with microservices. So we sort of treat them almost as if once I've got microservices, I'm cloud native, and if I don't have microservices, doesn't matter what else I'm doing, I'm cloud native. One of the definitions of cloud native is that it was born on the cloud. So with this, an app is cloud native if you had the cloud in mind when you started writing it. So legacy code, by definition, is not cloud native, which is, I think, a bit rough for the poor legacy code. A lot of the ideas of cloud native are actually, if you sort of look at them, pretty similar to DevOps, that sort of continuous deployment, that working in small batches, that working across the whole team. They're also pretty similar to what we used to call 12-factor applications. So if you write a 12-factor application, you're on a good path to becoming cloud native. One of the things that I've noticed, which kind of makes me smile, is that we've got so used to saying cloud native, we forget that you can say just cloud. So it's like when you start to say the word cloud, you just have to add native onto it, even though actually they're two different things. We can be just cloud. And also, because cloud native is so much something that we all want to be, in 2022, nobody wants to be cloud foreign. We sort of just take all of the development practices that we think we should be doing in 2022 and just sort of bundle it into this big pile and call it cloud native. So if we mean it was written in 2022, we say it's cloud native. A more technical definition for cloud native is that things behave really well if you shut them down and start them up again. A lot of our legacy systems really didn't do this, which is why they were not cloud native. And the technical term for this is idempotent. I don't think this is a definition that we use very much because idempotent is hard to say. And then finally, increasingly, a lot of us are talking about taking those poor old legacy apps that I said couldn't be cloud native and migrating them to be cloud native. So it's like it's the same app, but it's on the cloud, so we call it cloud native. But when we go and decide on the architecture for our system, how do we choose? Usually what happens is we go to the architecture shop, and there's something that's really in the front of the window. And there's a monolith, and it's kind of old and dusty, and it's at the back of the shop, and nobody wants that monolith anymore. We all get the microservices that are at the front of the shop, whether they're the best thing for us or not. Because architecture, like pretty much everything else that we do, it's really driven by fashions. And in 2022, the fashion is microservices. And we know that if we do microservices, we're going to look good. We're going to look clever. We're going to look like we know what we're doing. And that's kind of a cynical point of view. You think, surely none of us would actually make architectural choices just because they make us look good. The evidence is that we do. Red Hat did a survey, and what they were looking at was the drivers for container-based development. And they found a few things. So one was better supports for business groups, new types of application service. But 40% of people said career progression in-house or externally. And that is exactly CV-driven development. But actually, I think I probably am being a little bit too cynical. Because the thing with cloud native is it doesn't just make us look good. It's really, really exciting technologically. If you look at the CNCF landscape, there's so much in there, and it can be a little bit overwhelming, but it's also incredibly exciting. You look at those projects and you say, oh, I want some of that in my stack, and I want some of that in my stack. Because that landscape, it's not just a landscape, it's a catalog of things that we can bring in to play with. And they're all kind of exciting and kind of shiny, and we kind of want them all. So then that comes back to, well, yeah, we want them all, but should we have them all? And the answer to that comes back to, well, what problem am I trying to solve? Sometimes, as Kevlin talked about this morning, the problem we're trying to solve is that my CV does not have microservices on it, and I'd like to fix that. Sometimes the problem is a little bit more technical. My problem is that there aren't enough containers. We can fix that, but Why did we fix it? Why did we need more containers? And usually we need more containers. It sort of comes back to this conversation about microservices. You say, we've decided we're going for microservices, and so we need lots of containers. But the thing with microservices is they look so neat. They look so tidy. And then you open the lid, and sorry, that was really loud. I'll try to refrain from screaming in future. And then it gets worse, because you look at the ingredients on your tin of microservices. And there's some health warnings there. Inside your microservices, you may find coupling. You may find cloud-native spaghetti. And you may even find a distributed monolith. Those microservices might not even be microservices. Because when we look at something that claims to be a microservices architecture, we have to ask really closely, is this actually microservices? Or is this just a distributed monolith? Because a distributed monolith, it's kind of got a lot of the bad features of a monolith, but it's also got all of the bad things that happen if you distribute your application. So you don't get that compile time checking that comes from having an IDE which knows exactly what kind of system you're operating in. You don't get that kind of guaranteed function execution that you get if you're all running in a single process. You try and invoke whatever it is you're trying to invoke, but it's over there. It may be paying attention. It may not be paying attention. You have no idea. You need to handle both scenarios. And so when we think about moving to microservices, we really need to not think about moving to microservices as a goal. You know, we should never be saying our organization needs to move to microservices. Microservices are the means to achieve some other goal, and you need to figure out what that other goal is, because you're probably going to need to do other things as well to get that other goal. And as well, microservices, they're not the means, they're a means. Usually we can get the same thing with other ways. And I think we sometimes imagine when we think about microservices that the cloud nativeness comes from those connections between those boxes, but that's not how it works. What you get from those connections between the boxes is pain. So if you remember the distributed computing fallacies, okay, hands up, who remembers the distributed computing fallacies? No hands, as I thought. The thing about the distributed computing fallacies is we always forget them. That's why they're called fallacies, is because we sort of imagine that this time the network is going to be reliable. This time there's not going to be latency. And of course, in 2020, we all discovered, it turns out the network is not reliable. I can't tell you how many times I was trying to do something and then the network died. And I'd add one to these fallacies as well, which is that distributed is not the same as decoupled. So when you think about, when you're in the architecture shop with your list, there's a lot of reasons why maybe microservices aren't the right fit for you. If you've got a small team, it's just not worth the overhead. If you're never planning to release the parts of the system independently, not worth it. A lot of people, when they think about how they're going to handle the sort of the holistic concerns of the system, how they're going to handle the communication between the components, they sort of start to have that question, and someone says to them, you need a service mesh. And they said, oh, no. I've heard about service meshes. Those are really complex. I'm not going to have a service mesh. Instead, I'm going to write something that does my security. I'm going to write something that does my communication. And actually, at that point, you have a service mesh. It's one that you wrote, and you have to maintain it, which is worse. Sometimes as well, the domain model just doesn't split nicely. And I've seen this. One of the first microservices projects I did, I was a consultant, and I was called in on a rescue mission. And the first thing that they said to me when I arrived was, every time we touch one microservice, all the others break. Now, if you've been paying attention, this is exactly how microservices are not supposed to work. They're supposed to be independent. But this comes back to that fallacy. Just because they both start with D, distributed and decoupled, they're not the same thing. You can be totally distributed and still have a really terrible coupling. How do you know if this has happened? A good heuristic for this is, can you deploy these things independently? Because that's one of the main benefits of microservices. And a good heuristic for knowing if you can deploy these things independently is if you are deploying them independently. And the way to check that is to just look at the version numbers. So a consultant I know, when he goes into a new project, he just looks at the version numbers on all of the microservices. If there's no version numbers, then he knows we're in a lot of trouble. If the version numbers are the same on every microservice, something's not right. What we really want to be seeing is something where we see evidence that these things are being deployed independently. But what often happens instead is the opposite. Often we're so scared of deploying these things independently because everything might break and how do we test it, that we instrument the pipelines to enforce that everything goes out at the same time, that it's physically impossible for things to be deployed independently. This is bad, by the way. But sometimes, actually, it's not like the problem is that we're deploying everything at the same time. The problem is that we're not even deploying everything at all. Some organizations really seem incapable of releasing code with any kind of ease. So when you look at the version numbers, and they're all on 1.0, and they've been on 1.0 for 6 months, or they haven't even got to 1.0, then you've got an even bigger problem. And the thing is, there's lots of ways to release really safely. There's lots of ways to release code that's maybe not ready really safely. And so the first thing that you want to be doing is you want to separate the idea of deploying from the idea of releasing. They're not the same. You can deploy something, you can get it out and running in the wild on a server, but you don't necessarily have to wire anything up to it. If nothing's wired up to it, that thing cannot do any harm. Or you can use feature flags to dynamically control your scary code so that you can roll it back without having to do a full release. You can do more measured things as well, so you can see what happens to your system in production in a really safe way, which you should be doing. So you can do A/B testing, you can do canary deploys. But unfortunately, I think these are not done as often as they should be. And I think part of it is that we've been lulled into a false sense of security by CI/CD. I always worry when I arrive somewhere and the team says to me, oh yes, we have a CI/CD. CI/CD, it stands for continuous integration and continuous deployment. Those are verbs. So a CI/CD, that's something that you do. It's not a tool that you buy. It doesn't matter how much Jenkins you have. It doesn't matter how often your Tecton is chewing away. If you're not actually integrating and you're not actually deploying, it's not CI/CD, it's just Jenkins. And of course, these ideas also sound a lot like DevOps. And as I mentioned, you can't buy DevOps either. And you can't hire a DevOps, or you shouldn't hire a DevOps. Because CI/CD, it's a verb, it's something you do. But what I often hear is, we have a CI/CD, and I'll merge my branch into our continuous integration system next week. If it's only getting changes into it once a week, that's not continuous integration. And if you have a CI/CD, but you're only releasing every 6 months, that's not continuous deployment. And it seems like we've sort of almost forgotten what the word continuous means. We sort of think of continuous as something that happens every 6 months, that happens once a week. That's not what continuous means. Continuous means we should be doing it really often. But this can be challenging for businesses. One of my colleagues, he spoke to a large bank in Asia Pacific. And they were really struggling. They were a legacy bank. Their lunch was getting eaten by these challenger banks, and they could see that the problem was that their IT was going too slowly. So they said, we need to get rid of this COBOL estate that we have. We need to move to microservices. And so my colleague said, yep, we can help you with that. Great. And then they added, our release board meets twice a year. So it doesn't matter how many microservices you have. If your release board only meets twice a year, you can only release these things twice a year. So they may as well be a monolith. You may as well get the compile time checking. But in general, what we see is releases are big, scary, and we do them very, very rarely. And there's sort of so much ceremony around release. So we sort of end up, I say, can we release? Why can't we release? And the answer comes back, well, we can't actually release this microservice without the release board. And we also need to test it with all the other microservices because we haven't done contract testing. And so we need to release them all at the same time so that to manage our testing costs, because there's a manual QA cycle. And of course, then we still have to do the release checklist. And then there's some incantations. And we need to do a bit of a death march. And we need to sacrifice a goat. And then, of course, there's a 60-tab spreadsheet that we need to fill in for every release. And the moon needs to be in the right phase. And the list of requirements goes on. And when it's that complicated to release, of course releases don't happen often. But the thing with releasing is it's exactly like brushing your teeth. If it hurts to release, the solution isn't to release less often. The solution is to release more often, and then you get the automation in place, and then it becomes easier. But of course, it's easy to say, release more often, but it's scary. Because often organizations are really reluctant to release because they don't have confidence in the quality. The reason they don't have confidence in the quality is because the tests aren't automated, or the right tests aren't automated. So we should fix that. Because if we don't have automated testing, basically what we're saying is, I maybe know this individual microservice works, but I don't know if it works when it's part of the system. But if you're going to be spaghetti, at least be tested spaghetti, and then at least that fixes some of your problems. Because when you end up in these systems where it's all spaghetti and everything is it becomes really difficult to release. It becomes really, really difficult to add those features. It becomes difficult to do those refactorings. It becomes difficult to do the things that we want to do to make better software. And certainly in large enterprise organizations, what we often see is something that we call the enterprise hairball. And so in these kinds of systems, we'll usually have a few parts of the stack. We've got the business layer. That's the layer we control. And we've divided it into microservices because it's 2022. But then there's a few other layers. There's a front-end layer. There's a database layer. In really large shops, there's probably also an integration layer. And what we realize is that even though our system is in microservices, we actually can't change anything unless the front end is also in microservices. But then we realize we still can't change anything because every change we make needs something to happen on the integration layer, and every change we make needs something to happen on the database layer as well. So we need to be thinking about getting that modularization, whatever we call it, in those layers too, and get them into smaller units so that we can deliver work in smaller batches. And in order to make that work, really we can't just be thinking about microservices, we really need to change how we do operations. And so the new thing there that we want to be doing is we want to be doing SRE, so we want to be doing site reliability engineering to make sure that we can be testing in production, to make sure that we have the automation, to make sure that we don't have people doing toil, that we have people working on how to make the system more resilient instead. But we also need to change how we think about risk. In general, the job of large parts of the business is to try and reduce risk. And they will try and reduce risk in the way that they know how to do, which is the way that worked 10 years ago, 20 years ago. But that is no longer the right way. I mean, I'm not sure it was ever the right way to reduce risk, but it definitely is not the right way to reduce risk now. And so we need to be having conversations with our leadership to say, look, these things that seem to be reducing risk are not actually reducing risk, they're increasing risk. Let me present you the evidence, because I care about risk as well. And we want to be de-risking through automation, rather than just through generating more and more paperwork. Because the governance habits that we used to have, they just don't work with the cloud anymore. They make the experience so much less appealing for us as developers, and they don't actually reduce risk. So what's the point? It makes me so sad when I see organizations where there is cloud capability, but it behaves as though it's not the cloud because of so much governance wrapped around it. I heard a story, this wasn't actually me, and this was many years ago. A colleague at IBM told me this story. It was sort of, I think it was probably before really the cloud as well. It was sort of just the early days of the cloud. And they sold someone this provisioning software. And they said to him, it's amazing. And then the customer came back and said, no, IBM, this provisioning software you sold us, it's broken. It doesn't seem to work at all. Because you told us that this software could provision an instance for our developers in 10 minutes. But what we're actually seeing is it takes 3 months to provision the software. And so we imagined that somewhere there was a broken cable, and they were taking each little bit of the image and putting it in a little basket and carrying it across or something. But when we investigated to figure out what was wrong, we found there was an 84-step pre-approval process. So anytime anybody requested something, one part of the organization said, oh, let me just do an approval on that. And then another part of the organization said, oh, and I need to do an approval. And then once all of these approvals added up, it was 84 steps. So no wonder it took 3 months. So I've talked a lot about the things that you can't buy. But I want to mention one thing that you can buy, and that's why a lot of this governance is in place. The one thing that you can buy is cloud. And not only can you buy cloud, you can buy a lot of cloud. You can be on so many providers, and on each provider, you can have so many instances. And you may not even know how much cloud you have. And you may not even want all of that cloud you have. And basically, it's just kind of burning money on the internet. And I think this is something that's probably happened to all of us. When I was learning Kubernetes, I provisioned a cluster, and it was quite a well-spec'd cluster. So it was about £1,000 a month. Unfortunately, I had too much work in progress. So I provisioned this cluster, and then I forgot it for 2 months. And then I came back and I discovered that there was this cluster that had been there just sort of burning money, not doing anything even remotely useful. It wasn't even Bitcoin mining, it wasn't serving Minecraft, it was doing nothing for anybody while costing £1,000 a month. And what I've since discovered was that although it was kind of careless and silly of me to make this mistake, at an organizational level, this happens all the time. Every organization in the world, as far as I can tell, doesn't really have a good handle on their cloud bills, and they wish it was lower, and they can't quite figure out who's using what and whether everything is still needed. And then we sort of try all sorts of techniques to manage this. And sometimes it's not £2,000, to a large company. Sometimes these cloud accidents can be really expensive. So there was a lovely story a while ago about a little startup, and they thought they were using a free tier, and they were not. And they thought they were using something really innocuous in Firebase, and they were not. So they made a change, and then they went home for the weekend, and then they came in on Monday morning to discover that they had a $72,000 bill. And so that was the end of that startup. And this can happen to everyone at all levels. If you've ever used haveibeenowned.com, Troy Hunt, who manages that, he made a tiny, tiny little error in his caching configuration, and he ended up getting a bill for $11,000 because all of a sudden he was having way too much outbound traffic. And so this can be a real problem, that we sort of have all of these cloud bills and it's just a money pit and we don't know what's going on. What I find good is we are starting to see some solutions in this area, and we are starting to see progress. So what Spotify have done is they have a tool called Backstage, which is now part of the CNCF. And what it does, which is interesting, is it makes cost management an engineering concern, which makes a lot of sense, right? We should be aware of what our architectural decisions are, the cost implications of them. We don't want them to be so decoupled that we then have these really long feedback cycles where we sort of choose a database and then 3 months later someone comes back and says, by the way, our bills have doubled. It should be really visible, because when it's really visible, we can optimize it. And of course that has a financial benefit, and it also has a sustainability benefit, because we want to bring that information about the carbon impact of our choices as close to the decision maker as possible so that we can make more sensible choices. And what they're seeing with Backstage is they're saving a lot of money by doing this kind of shifting left of that information. And I think this is something that we should adopt more widely. Because of how we operate our workloads, cost isn't just an accounting concern, cost is an engineering concern. So give us the information to do it. And we're seeing, I think everything has been opsified, right? So we have DevOps, we have design ops, we have chat ops, basically any word that you can take, you can tack an ops on the end. And I think one of the more useful ones is FinOps. So FinOps is trying to bring some of this automation, trying to bring some of this real-time visibility of what's going on to financial information. So instead of having it be something where we get our bill at the end of the month, let's see right now who's doing it, and let's see it with enough observability information, with enough metadata, that we can actually track these costs to the source so that we can make more informed decisions. So I spoke about what you can't buy. And then I spoke about sad cloud cost stories. But I don't want to finish on a really miserable note, because I do want to talk about some of the things that are going right with cloud, because I think cloud does have the potential to reduce so much friction for us as developers. And things that were so hard 10 years ago are now so easy. And we have access to so much open source software, and we have access to so many ways of, so many run environments that aren't our laptop, which is a good thing. And we can deploy things so easily. We can get things out to people so easily. And that's all a really good thing. So when we sort of think about the things that we should be doing as part of cloud native, I mentioned it's really easy to start with a CNCF landscape and go, if I take everything on that, I'm cloud native. I don't think that's true. I think cloud native, it's about culture, not the containers. It's about how you get your value to users. And so if we want to sort of become a little bit less just sort of shiny technology than just looking at the products, maybe we start thinking about the architecture instead. How is our system put together? Oh, excuse me. Thank you. I was a bit worried after the shriek that I did before that if I sneezed on the microphone, it would be really awful for all of you. But I think we need to go not just past the products to the architecture, but then also to the operations. And then not just thinking about the operations, how are we releasing, how are we deploying, do we have observability, can we see what's going on in production, do we test in production? To then have that conversation with the business and say, so you know this cloud native thing, what problem are we trying to solve? Why are we doing this again? Because sometimes the answer will be surprising. Sometimes the answer is we want to attract developers, so we need to look like we have a modern stack. Sometimes the answer is we need to get products out to users faster. And if we know that answer, we can make better choices. So we can say, well, I don't really need the microservices because we're not going to release independently, but I do need the automation, or I do need the this, or we can more closely match what we're doing to what will be valuable for the business if we do it. And when I say cloud native is about culture, not containers, I think that sometimes culture sounds so fluffy. It sounds like, well, I'm a software engineer. It is not my job to think about culture. I did not become a coder in order to think about culture. I became a coder so that I could write ones and zeros and IDEs. So I think if culture sort of seems too fluffy, that doesn't mean it doesn't matter. It just means that we can sometimes, we can use a different word. So when we talk about that business driver, that's part of the culture. And when we talk about operations, things like releasing, those are also really part of the culture. So instead of talking about culture, we can say, well, I'm very technical, but I do want to talk about how we do our operations, and then we're sort of solving the same problem. And with those operations and with those business drivers, they are less tangible than a software stack that we can download, but they are really, really important. And when we think about cloud native, they need to be part of our thinking. And with that, I will let us in for the next break. So thank you very much.